If you know me, you know that I'm going to start with a story because that's what I do. And even though this is a super technical conference and you're all 10 times smarter than me, I can still tell you a story. I can do that much. So let's start. This is a real life story, right? This is true, and I would love to protect all the innocent, but there are no innocent people in this story. If you take a look at the way it's supposed to work, this is probably the way most projects work in your organization, right? You receive requirements, you design a solution, you build the solution, you test the solution, and you show it to the client. And the client says, this is great. And maybe there's a couple things they don't like yet, or they're not ready to launch yet. And so you release that which they say yes to. What they don't like, you put in the no column, and you go through another round of this ad infinitum. The story I want to tell you about, the project that we worked on, has nothing to do with this, right? It's when you receive requirements, design a solution, build a solution, test and show the client, and the client says at that point, wait, let's add this other stuff onto it. Now, the first inclination in all the best practices and everything we know is that we tell the client, we manage expectations, we tell the client no. Totally makes sense. I say no a lot. Like if you go Google people who say no a lot, right? I'm right up there at the top. So I have no problem saying no. Except then the client says, well, this is a $700,000 project. Do you know who we are? In which case you say, yes, we know who you are. Okay, we're on it. Because certain size organizations and certain kinds of projects, the client tells you, this is what needs to happen. And you just say, okay. And so that's what happened. And the project timeline tells the entire story. The hope line, right, says, okay, there was discovery, then there's a short statement of work, and then we go to do the development, and then mid-September we launch. It's a beautiful narrative. It bears no resemblance to reality because what happened was that the statement of work and contracts took 2 months rather than a couple weeks. And then when development still started late, we started doing development, and then in mid-September when we were supposed to launch, they say, oh, this main part of the site we want, we're going to introduce a new third party, another organization that's going to do some of this work, and we would love for you to integrate with their API. You go, okay, it's an API, right? I mean, instead of dropping in video with OEmbed, you're going to just make some calls. It's a REST API. This is going to be great. No problem. I can pull through the JSON and be fine. Except the API wasn't done. So you can imagine developers who are like, okay, well, hey, just give me the documentation for the API. They're like, yeah, we're working on that. We'll get that to you. Here's some sample code that should work. Should being the operative term. And so we enter the danger zone. If you don't know how to define the danger zone, here's my definition, or at least one definition. The portion of the project where all your profit disappears and you're wondering, how the hell did we get here? Because now you're spinning in cycles, co-creating with a client or co-creating with a partner, something that isn't complete. You're trying to call an API that doesn't exist, and you're trying to work it through. Now, some people say, well, that's just the client. The issue is the client. We need to deal with the fact that the clients do this. But let me be very clear. Clients are idea generators. They're idea factories. This is what they do. They come up with ideas. The more time you give a client, the more ideas they will have. There's absolutely nothing wrong with that. Other people will say, no, the problem is the developers, right? Developers get anchored, they're told this is what we're gonna do, and so they get completely locked into, if this is what we said we were gonna do, then this is what we're gonna do, and any aberration or any departure from what we said we're gonna do, that's the problem. And you go, no, the problem isn't actually developers either, right? Here's the truth. It's neither. The problem is not the client. The problem is not the developer. Let me tell you a little specifics about this project. Now, this project isn't necessarily huge for all of you. I know some of you worked on very, very large projects, but there were over 4,000 commits and 12 people that were involved in the coding of this project. Now, at most, it was typically about 5 people at a time, but because it took 8 months, different people had to shuffle off into another project, other people had to come on board, And so what ends up happening is you have a lot of people who are making lots of little choices. And that brings us to the core of the problem. The core of the problem is our brain and our memory. I don't know how your organization works, but I polled our team, and at Crowd Favorite, we have 0% people who can remember with perfect recall every decision they and any other person on their team has ever made, and what those dependencies may relate to as you start making changes late in a project. I won't ask for a show of hands, but my guess is that every one of you, after you have finished 50, 60, 70% of a project, have had a customer at minimum show up and say, can we make this change? And most of us don't have staff that can go back and say, well, you know what? If you're making this change, then here are the 14 things that it's going to impact on all the existing code base. Most of us can't do that. We just go, oh, I can remember one or two places where it's obvious, and we'll go work through those. And we leave other parts that are like, oops, I forgot about that. When we talk about impact analysis, what I'm talking about is the ability to determine when a client makes a new request or a change of scope, the introduction of new code into a project that's existing, what effort do you have to take to figure out the impact of that change on all the preceding code? Now, I don't know how your decision tree looks when you make choices for code. But in our organization, it looks something like this. Somebody has an idea, someone makes a choice, that choice automatically creates another choice. From that choice, there's a dependent choice, like, well, obviously, if we're going to use this technology, then we need to do it this way, or we're going to use this library or this framework. And so we make additional choices, and then we write some code. And when we write the code, we go, okay, let's test this out. Oh, it looks like it's not very performant, and so we write another version of the code. And maybe they go look somewhere else, and they see someone else's code. They look at another article or snippets, and they go, oh, that just looks really good. Let's see if we can pull it into here. And so then that external code comes in and makes a change. Then you start talking with some people. Maybe someone else comes over to talk to you about something. And ultimately, that leads to an insight, which leads you to make a different choice, which causes you to run through the whole thing again. And I'm going to make a guess here. Most of the time, you don't write down every one of the steps of that journey. Just happy the code works. Like, yeah, there it is. It's working. We're good. No issues. And you forget that you went through this entire process to figure something out. Now, I want to be clear. The issue here is not change orders. This is not a financial dynamic. We're not talking about the fact that at the end of the day, if a customer shows up and says, I want these changes, you go, well, the way to deal with that is just charge them money, right? Either you'll make more money or they'll say, well, I don't want it that much, and they'll back up. Most of the time when this happens, we start thinking about it as a financial issue. It's not a financial issue. It's a risk mitigation issue. Because at the end of the day, we did charge, right? We charged in that zone. We charged all sorts of money for change orders. But that is only for the changes. You can only charge a client for new work you're creating, new stuff you're developing, effort that you're going into. It turns out you can't charge them for mistakes in your old code that just broke at your own hand, right? Another way to define the danger zone is because you're like, look, here's a whole bit of code we had to go back and rewrite because we made new choices. Those new choices introduced new code. That new code broke the choices in the old code that we'd written. And that impact analysis, that ability to determine what is this going to have consequence on, right, is very difficult to mitigate when you're trying to put in a change order. Because what are you going to put on the line item? Fix all our old mistakes? Right? It's not going to play out. I realize at this point I've talked so long without quoting Plato that it seems like it's the appropriate time to do so. But Plato says, everything which is done orderly, with measure, and according to rules, generates something good. And you go, okay, that's the way we want to work. But the truth is most of us aren't very orderly, right? And there's not tons of order in the process of last-minute changes when a client shows up and says, hey, I'd like to introduce this, or I want you to integrate with this, or I want you to partner with this, or here's some code that our internal guys have written we'd like to roll in. So I'd like to tell you another story, a story about how I came upon this notion of automated, structured, orderly impact analysis through automation and tools, right? I got called in after about 2 years of developers working on software for the Pacific Stock Exchange. The Pacific Stock Exchange no longer exists, but it was a options board in San Francisco. And if you've seen trading places, you remember the dynamic where people are on the floor and they're calling out offers and bids, and other people are making purchases, and they're doing this whole back and forth all personally in the pit, right? Well, by the time I got involved with we were moving towards electronic boards, right? Where the transactions were all being done by engines that were processing a trade. And so what would happen is if you were, and this was a particular options board, so if you were, someone wanted to sell Microsoft May 50s, meaning this is an option in May that it's going to be at 50, and so you want to sell that, right? Normally, in the real life person, someone would raise their hand and say, I want to sell this, and then several people would show up and say, I want to buy it at that price, and you got to pick who you were going to sell to. And in this scenario, they're like, no. We want the system to figure out who's going to get the allocation, right? We'll divvy it up and we'll go from there. And so they had all these people working. It had been 2 years, and they were finally rolling out some beta testing, and they had performance problems. And they had serious performance problems. Now, this was in the old days where we did something called message-oriented middleware, or messaging as ways to send bits of data so that different modules of software that you would write would essentially either publish new information or subscribe to a particular channel to get that information and then be able to act from there. Those were the triggering events of the software platform. So I came in and I just asked the question, well, how many total messages move through this system when someone wants to do a full transaction? And everybody's looking around at each other like, I don't know. Because nobody was looking at the bird's eye view. No one was looking at the full picture. Everybody was working on their own little module. I asked the second question, which is what happens when a message doesn't get all the way through? And they said, well, if it doesn't reach its destination, we send it out again. And so you can imagine what's happening as they're resending information because there's congestion. They're just creating more congestion, creating gridlock. I was not smart enough to solve this problem, but I'll just make a plug for this is why you should hire old people, right, in your organization, because old people have tons of knowledge and experience through errors and issues and stuff like that. So I just went to the oldest guy I knew who did this kind of stuff and said, hey, how do you solve this? He goes, well, we use Rational Test Suite, which has a rational robot, and we can automate these tests so we can run all the way through. And I can tell you, before the developers can, I can tell you the total number of messages that are going to go back and forth in a transaction. I'm like, do it. And we solved it. And on that day, I thought, wow, this is automated so that, like, how are you doing this? And we started digging into it. Impact analysis. The main case I want to make for this morning. Impact analysis is easier and faster with a tool or a library or a package called Codeception. And I don't know if you've played with Codeception, right? But I want to talk to you for just a second about acceptance tests. When I said, here's how you make all those decisions, and a lot of people don't know how to make those decisions, and they don't remember to write them all down, right? The reality is that most of us do, when we think about testing, we think about unit testing, right? We think about testing our own code. And as a developer perspective, you're thinking, I wrote this code to do something, let me write a test to check it out. Yes, it works, good. But I'm talking about testing from a different perspective. I'm talking about looking at the entire transaction from the perspective of a customer so that you understand their expectations and the expectation logic that goes into it. And how do you create tests like that? Well, those are acceptance tests, right? So a test, when it's written, will look like this. As a, whatever role you're in, right? I want to do some feature so that, and you articulate a benefit. Right? This is how you would write it. When we go to program an acceptance test, it's more like you give it a title and you say, given this context, when this event happens, this is the outcome I'm looking for. This is what I'm looking to test. Right? For us, here's a sample. I promised I'd put code in my slides. So here is an example. It's a very simple test. Right? As a subscriber, I want to edit my profile. I'm on this page, and I can see this information. And if you were to type if you were going to the command line and put in codestep.far, generate scenarios, what would happen is it can translate that into actual English, right? Which is really helpful for customers, right? Because the customer can actually see, I want to edit my profile, I'm on the page members/edit profile, and I can see personal information. So you can actually run a command that outputs all the scenarios, and you can put it in front of customers and say, this is what we're trying to accomplish, right? Are we on together on this? And they'll go, yeah, that's exactly what we want. Great. And Codeception ends up having a whole bunch of commands. You don't have to just use those. I'm on this page, I look forward to, I can see a link. For every C, there's a can't see, so you can check, hey, I can't see this link yet, or I can't do this. I don't see this element. Click, fill field, select option. You have a whole bunch of stuff there that you can use. Now, ultimately, getting started is really, really easy. You go to the command line and you type in a wget command that will pull this library into your project. You pull it into the root. And then you type codecept.far bootstrap. And what that does is it actually sets it up in your project. It'll create the acceptance tests and test subfolders in the project. And then you can go type in the generate sep acceptance welcome, which will actually create welcomesep.php. And that's the one you can open up, right? In test acceptance welcome sep PHP, you can open it up and put in your first test. You go in and put your application URL or the root URL of your project into the YML file, and from there you hit run. And it will automatically run through, run the tests, and will actually tell you exactly how you're doing. It'll show you, well, these 3 things passed, this hasn't passed, etc. For our really big project, we created 395 of these tests. We didn't create them at the beginning. I wish we had. We created them in that mid-September point when things started falling apart, where we had to start introducing things, and we didn't know what was breaking. We didn't know if it was the call to the API. We didn't know if it was the decision we had made earlier. We didn't know what was going on. So we started writing these tests so that at any point when we were making changes or making decisions, we could run back through. Now, did we need 395? Probably not. We're still learning how to choose the right ones. But we did automate the process, right? What happened for us was whenever anyone did a push into Git or in our private repo in GitHub, right, the repo would check, and we were using a tool called Scrutinizer, which is a continuous integration platform, and Scrutinizer will check to see if this is a repo it's listening for, and when it checks to see that it's listening and says yes, then it says, okay, great, I know how to pay attention to this, and then it goes and looks in GitHub, in the repo for the tests subfolder, and it goes and grabs all those tests, and it runs them. It runs all those tests and determines whether or not any single one of them has failed. And if any of them has failed, it stops, right? It just gives you the notification. But if they all pass, then it passes the trigger back to Scrutinizer to say, hey, call Capistrano now. We can actually do a deployment. We can move this code forward to a production environment because we've passed all the acceptance tests. At the end of the day, right? Speed is not the issue. I mean, speed is an important dynamic in what I'm talking about, but I'm not talking about speed in terms of this will help you write code faster. I'm not saying this will help you even create automation tests or acceptance tests any faster, or that you'll learn which tests are the right tests. What I am saying is the whole point of this is for you to find out as soon as possible when a new introduction, when a new change is happening, and it's going to cause something you've done before to break. Because the worst thing you can have is that experience with a customer where they say, well, I was going through it, and this stuff that used to work is no longer working. Any of you been there? Right? The client is the one that tells you. You don't want the client to tell you. You want to be the one that catches it first, and you want to be the one that makes a change. At the end of the day, right, Winston Churchill said it best. It's not about strength or intelligence, right? It's about continuous effort, a continuous goal of getting better and smarter and faster at what we do. So I'll end with one last story. You may have read about this, you may have seen it, but it relates to another trading group called Knight Capital. And in August of 2012, Knight Capital decided that they were going to roll out a new execution engine for their trading, right? Now, in the same way, the stuff that I'd worked on the options board of the Pacific Stock Exchange, they were doing something where they were creating a new algorithm, an engine that would take the large parent orders, the big orders, like those Microsoft May 50s. Let's say you wanted to sell 10,000 of them. Well, you're going to sell them in chunks. And the Knight Group was well known because they were running about 10% of all the transactions out there. Right, on the New York Stock Exchange, 10% of the transactions were running through them. $3.5 billion 3.5 billion transactions a day. $21 billion running through their hands. And they were a market maker. A market maker is someone who essentially commits to buying, and they put liquidity into the markets because they buy and they sell. They play the middleman going back and forth. They create the market, but everything they buy, they have to ultimately sell because they don't want to hold any of it, right? They're just the guys doing the transactions. And so on August 1st of 2012, they deployed some code. The code went, over the course of several days, it had gone to, or was supposed to go to 8 different servers. It only ended up going to 7. And so in the cases of the 7 servers, when a parent transaction would come in, it would get decomposed into a whole bunch of smaller child transactions, which would get sent from the engine out, and they'd go place orders. On that day, they made $3.5 billion worth of longs, right? Long-term purchases, and $3.1 billion of short. Now, they had $365 million in their account. And I don't know about you, but for me, I think with $365 million, that can pretty much solve every problem. Almost. Because it turned out on that 8th computer, they had activated old code that was sitting in the platform that hadn't been used. They'd activated it. They had no restrictions or management around it, so it started buying wildly. Transaction volumes went up. Everybody started going, what's going on? Most people thought, well, this should stop right away because automated systems have a trigger to pull it off. But this code didn't have any control over it, and so it just kept going, and so it just kept buying. And so in the end of the day, let's count it off. Most of you are annoyed by silence, especially when someone's presenting. But you should really be annoyed. We just burned $5 million. They were burning $10 million a minute. You go, that's insane. And you go, yeah. But let me make another guess today. None of us wants our name to be in an SEC filing. That deployment was manual. The guy who blew it just blew it because he just didn't do it on the 8th box. We do our deployments in an automated fashion, and more importantly, we do them by making sure we run them through acceptance tests first. Not just our unit tests, not just our internal stuff, but the ability for us to know that from an end user perspective, we're making sure that we've done the right stuff. And to that end, none of us want to be in that place where they lost $440 million in 45 minutes. Remember, they only had 365 in liquid assets. So they ended up having to go get the next day, literally the next day, an infusion of capital, which ended up causing them to sell their company. They are no longer the largest and 10% player of all the markets with 17% market share. The Knight Capital Group learned the hard way. You can make software decisions that can really hurt your bottom line. There's a whole bunch of resources at Codeception, and also one of the guys on staff, a crowd favorite, Brian Richards, also you may know him from WP Sessions, has created a little video on it. You can find these resources and the slides themselves all at SlideShare under my CF Lemma account. Thank you very much.